Hi, today's topic is about partial fractions, and we're going to have another problem about the decompositions of the fractions p's of x over q's of x, where the denominator q's of x has repeated linear factors. No? So we have one problem here, 5x squared plus 36x minus 27 all over x to the fourth minus 6x cubed plus 9x squared. First, we're going to factor the denominator, no? So, upon factoring, we get here x squared, no, the common factor of this trinomial here, times quantity x to the 4, x squared minus 6x plus 9, no? So, we can still factor this further. So, factoring again the denominator, we get here the linear factors x squared times the quantity x minus 3 quantity squared. So, we're going to decompose this into partial fractions, and we substitute all the constants here, a, b, c, d, to represent the numerator, no, of each of these partial fractions. So we have a to the x over x plus b over x squared plus c over x minus 3 and d over x minus 3 quantity squared. So having this, no, this portion here, we will get the LCD of the whole equations, and this one will be our LCD, x squared times quantity x minus 3 quantity squared. So to get rid of all the denominators, no, we multiply the whole equations by the LCD. No? We multiply all these whole equations by the LCD. Upon doing that, we get 5x squared plus 36x minus 27. No? And this portion here is equal to a times x times quantity x minus 3 quantity squared plus b times quantity x minus 3 quantity plus quantity squared plus cx squared times quantity x minus 3 plus dx squared. So upon doing that, as you can see, we can cancel out some terms here, no? If we set x is equal to 3, we can cancel out a, b, and c, no? And what remains will be x, dx squared. So we set it. So 5 times this one, no? We set x is equal to 3. 5 times x squared, 5 times 3 squared plus 36 times 3 minus 27 is equal to, no, setting x to be equal to 3. So it's equal to 3 squared d. Simplifying the whole equations, you get d is equal to 126 over 9. So d will be equal to 14. No? Because upon substituting, we get 45 plus 108 minus 27 is equal to 9d. And finally, we get d is equal to 14. And again, we set again the whole equation, but we set x is equal to 0. So in doing that, no, this term here will be equal to 0. What remains is equal to negative 27 is equal to, so this one is equal to 0. And also c and d is equal to 0. What remains is b times quantity 0 minus 3 quantity squared, no? Simplifying, we get negative 27 is equal to 9b, and we get the value b to be equal to negative 27 over 9. So b is equal to negative 3. So we get two values for now for our partial fractions, which is d is equal to 14 and d is equal to negative 3. No? So it will be very hard for us to get the value of a and c. So to do that, we use the equating coefficients method. So we expand, no? We get this 5x squared plus 36x minus 7. No? So this portion here, we expand, we get ax, if we expand this, x squared minus 6x plus 9, plus b, we expand this binomial here, x squared minus 6x plus 9, plus cx cubed minus c times 3 x squared plus dx squared. So we equate the equation of x squared. Equating that, we get the coefficients of all the x squared here, 5, and the coefficients of ax times negative 6x is negative 6a. So bx squared is b, and negative 3c and d. But if we examine this coefficient of x squared, we can see that we still have two unknown values for a and c. So it will be hard again for us to get these two values here. So we continue equating the coefficients of the equations to create the coefficient of x. Upon doing that, we get the coefficients of x to be 36. And this one, the coefficient of x is equal to 9a. The coefficient of x here is negative 6b. But we found the value of b to be equal to negative 3. So we substitute the value of b to this equation here. So 36 is equal to 9a minus 6 times the quantity negative 3. So to continue, we have b 36 minus 18. We transpose the value of positive 18. We get 36 minus 18 is equal to 9a, with the value of a to be 18 over 9 is equal to 2. So now we have three values for our unknowns. That is a, b, and d. So we can make use of the coefficient of x squared of this equation here. So all we have to do is substitute the three values for the unknowns. So we get the coefficient of x squared to be 5 minus 6 times 2, the value of a, is equal to negative 3, the value of b, negative 3c, the value of c is unknown, and 14, the value of b. So we look for the value of 3c, and we simplify this one, we get c, we transpose negative 1 there. 6 is equal to negative 3c. So c is equal to 6 over negative 3 is equal to negative 2. Now we have four values for all the denominator. The numerators of our partial fractions. All we have to do is substitute all the values of the unknowns a over x. So a is equal to 2. So 2 over x minus the value b to be negative 3 over x squared minus the value of c is 2 over x minus 3 plus 14 over x minus 3 quantity squared. So we make use of the combinations of setting the value of simplifying by setting the value of x to certain values, so that we can cancel some unknowns, and then we combine it with the equating coefficients method. So that's it. We can solve most of the problems in partial fractions by using these two methods simultaneously. So thank you again for watching our videos. Please don't forget to subscribe and continue clicking that notification bell. So thank you, and see you again later.